What we're in here is the Sukup atrium. This is the biorenewables complex. I don't need to tell you guys that. You already know that. But this is it was a $107 million project. BRL was completed first. That was occupied in 2010. Actually, we started planning for the entire complex in 2007. So we did the programming, planning, schematic design for the entire complex, knowing that we were going to build it all, but weren't sure when it was going to happen, which project was going to happen first. So we made sure that we did the design such that no matter what, we could build the other pieces. BRL was started first. It was completed and occupied in 2010. ABE, which is Ealing's wing, the building in the Sukup atrium, Sukup Hall, was completed this summer and just got occupied for this fall semester. We designed the facility to achieve LEED Gold, and we've got a number of sustainable things that we incorporate into this facility. And I think primarily we'd like to hear about stormwater management and stormwater control. So, which is great because that's really a passion of mine too, is stormwater, water control, water reuse. So what we have in this building is all the perimeter tiles, the drainage, the drainage off the roofs, all go into two 25,000 gallon storage tanks. We've got a vegetated roof on top of Ealing's. There's a vegetated roof in the lab building and the small building to the north. Two entrances to the atrium also have vegetated roofs on them. And so we've got that to use some of the storm water, but to control it. Out in front here on this atrium, below that, that's pervious. There's pervious concrete below that, which gives it a solid surface. And then there's several feet of rock below that. So that gives us stormwater storage out front. And so what we do is, so the water on the site, we either collect, control, slow down, reuse. So the water that goes into the 50,000 gallon tanks is used to flush toilets in all three buildings. So we reuse it that way. And ABE also will use that water for some of their research projects. They've got a flume, or will have a flume, and a rainwater simulator. They want clean water. Clean water to them is storm water. It's not city chlorinated water. So that was very important to them also, that they have a source of their storm water. When we picked this site, which was back in 2005, we had site selection all over campus, and this site was selected by the administration. The ISU Utilities, which is the Department of FB&M, came to me and said, make sure you keep $250,000 of your budget to replace, to increase a storm line that's in this side of Bissell, because they had a problem with, on large rain events, this line was not large enough, and it flooded State Gym and everything down. So they said, make sure you save $250,000, $250,000 in your budget to tear up Bissell, put a bigger line in there. So I did a little research, and I told them, I'll tell you what I'll do. I'll spend that $250,000 on the project. We'll reuse the storm water, we'll control the storm water, we'll slow it down, and we won't have to eliminate, we won't have to tear up Bissell, we won't have to replace that line. Plus, we'll eliminate your problem downstream, down in State Gym. Well, that's what we did. So there's the use, same dollars, and we were able to put it to better use, I guess is a good way to put it. So I like telling that story because it's a success story. And it took a lot of convincing for me to tell them that was going to happen, because this was, as you guys know, you've been here long enough, this was green space. This is where the band practiced. This is where, this was green grass. This is where all the water infiltrated. Well, we all know that the soils in Iowa, the water doesn't really infiltrate that well. So it was basically running off. It was almost like hardscape. So the idea was, let's devise as many plans as we could to control the stormwater. We've got a bioretention pond on that side of BRL. There's one on the west side of ABE. And so all the water from the tanks that overflows, with a large rain event that overflows, it can only hold so much, that'll overflow into the bioretention area. We figured, I guess we were a little bit concerned about will we be able to keep those tanks full, because we get a summer with a drought, and so we've got it set up so that we can actually recharge those tanks with fresh water, potable water, if we need to. That's not the case. The drought of 2 summers ago, 3 summers ago, whenever that was, where we just didn't get much rain, the tanks virtually stayed full because of the ground water table. We were always pumping water from the perimeter tiles into the tanks. So for this complex, during the initial testing of the entire system, everything, we used about 150 gallons of potable water. So that is all the potable water that we've used for flushing toilets in these buildings since they've been open. Everything else has been stormwater. I really should get the figure on how much water we saved. I don't have that. Maybe I can get that for you.
All right.
I'll try to get that for you. Because we meter that, we meter how much water we do reuse. So I just need to get that figure.
Okay.
So we had a number of different strategies on how to deal with stormwater management. And it's been very, very successful. So we've got all the equipment down in the mechanical room of BRL. This was, like I said, this was designed, built as a complex, so most of the utilities and services are in BRL basement. So when it came time to build ABE, we just connected to what was in BRL. We already have the taps in there. We had to enlarge some of the stuff, but basically everything's in BRL. So we can go down there. These are not the first vegetated roofs that we've got on campus, and we've got more now. This rainwater reuse, this is the third system. This is the first one. We've got 4 systems now on campus. So I didn't want to give you the impression that the only reason we did this is because we were forced to. This was going to happen no matter what. So this is the mechanical room, one of the mechanical rooms for BRL. We've got some of the air handler units down here. We've got chilled water, steam, all the utilities for this complex pretty much come in this location. What we've got here is the stormwater reuse system. I just passed out a schematic that has the system for BRL, which is the BRL ABE. We're using the same system for both buildings. So we collect the water out in the tanks, and then next to that is a kind of a site tank that gives us, it shows us how much water we have in the tanks. And we've got 2 25,000-gallon tanks next to each other that overflow into each other. The level stays the same in both tanks. And that is back in this corner. Did everybody get a copy? Now, I'm going to stumble with the system a little bit, okay, because I don't know exactly the system. So if I kind of stumble through this, bear with me, I guess. But so the column back here really tells us what the height of the water is in the tank. And you'll see this is low water. So we've got some ports in here that are low water cutoff, so we're not choking the system. We've got a high water sensor in there also. But this helps control the water level and tells us where the water level is. Generally, this hasn't been an issue. Like I said, the tanks pretty much stay full. The next cylinder is this cylinder right here. So from here on over, it's clean water, storm water. Let's call it clean storm water. There is a tap in the line over here, and that's where the water will go to ABE for their research. So all this water over here is clean storm water, hasn't had anything to do with it. From here on over is where we have to treat the water so we can put it into toilets. We had to work with the Iowa Department of Health and Safety. I don't remember the name of the department, but it's the Iowa department that's responsible for water management. Okay, they didn't really have a clue what we were talking about for stormwater reuse, collection and reuse. So we had to kind of teach them, and they learned from us as we were designing the project. They made us, we had no intention of dyeing the water because it's in toilets, so we weren't concerned about that. But they came back and said, no, you're going to dye the water so everybody knows that it's not good to drink. Okay. Now, I'm a little cynical here. I'm a little sarcasm. If by chance, it's a large building, and then there's pipes all over the place. If by chance there was a cross connection someplace, and we end up with blue water someplace else, well, we know we had a problem. So that was really their concern, is that we actually had a cross connection someplace, and we had storm water going to a sink someplace or a water fountain or whatever. So what they did was correct. So what we do is we get the water in here. We've got a series of pumps. We got dye. We dye the water. We circulate the water. It also goes through a UV system. So it goes through UV light to kill the bacteria. And then it circulates in this system here. So it gets dyed, cleaned up. Sand is all the sand impurities get screened out of it, and then it eventually finds its way back upstairs to toilets and around the building. It's a pretty simple system. There's a lot to it. There's a lot of controls to it. There really is not a whole lot. It's really not a complicated system. And it just, however, we had our problems with it. So we're still working through those. We want to make sure we do it right and we do it right the next time. We've got 4 systems on campus, and 3 of them were designed by different mechanical companies. They're all 3 different, unfortunately. There's little things that are different about them. What we're trying to do is get to what design works the best. So from here and into the future, we'll have a consistent design that we use. We've had a lot of people look at this. We've had engineering firms look at this. We've had other universities look at this. So this has been a good thing a PR item for the university for this kind of a system. When they installed the 25,000 gallon tank for VRL, they were just getting ready to put it in the ground, and I think I found out about it like on a Thursday afternoon, and they were going to do it on Monday. Actually, I was the project manager for the programming and schematic design. At that point, I handed off the VRL project to someone else because I just couldn't do it. My workload wouldn't allow it. Well, I found out about the fact they were going to put that tank in there. And so I asked him, I says, how do you plan on putting the second tank down there in a year, 2 years down the road? Once you dig that hole, everything that's around the first tank goes away, and basically you can't put 2 tanks next to each other one at a time. You got to do it together. So what we did is we called a silo manufacturer, the concrete above ground silos. You guys familiar with those at all? Like I said, I do the work on the Iowa State farms. I had a relationship with these people. I told them what I had. I told them I needed about 40 feet of silo concrete panels. They had them here on Monday. We put those in place, put the tank in, buried the tank. That way we could dig out on the west side of those panels when it came time to do ABE, put in the second tank.
That was pretty impressive.
Yeah, it was. The system really works out well, and I'll get you a volume on what we actually save on an annual basis for potable water. But why not use storm water to flush toilets? It seems like a no-brainer. I don't have to convince you guys of that.
So is the dye removed down here as well? Like, doesn't that dye have to be removed before it goes to sewer?
No, it's
Okay.
it's material that doesn't have to be.
Oh, okay.
However, there was an issue because what we thought about doing was going ahead and dyeing the entire system, which meant it would be in the tanks, the big tanks, but that wouldn't be allowed. That was not allowed to go into storm.
Okay.
That overflows into the rain garden, into the storm. That was not allowed.
Okay.
That's why we had to segregate the two systems, which makes sense. You didn't want blue water going into outside into the rain garden anyway. So. So is anything I've talked about so far contrary to what these guys are telling you? I'm just kidding. Kind of.
No, we actually saw a webinar just the other day. They had some big tanks installed, so yeah, makes a lot of sense.
You know, and we did all the calculations on how much storm water would be expected on this site. We had our one of our design professionals do all that. We've got all the calculations. And we actually added probably more than what we would do on a typical system. We did add a little bit more just to gain some more lead points. Lead, you're familiar with lead? To me, lead is a rating system, so that everybody's on a level playing field. We don't typically do stuff just for lead points. We do stuff because it makes sense. It's sustainable. It really does make sense. So we did do a little bit extra here. The plaza out front, that was kind of late in the game, but I felt like it was a good idea. It was another good idea to try and come up with a new design for pavers for around campus. You guys have been around in campus. You've seen we use pavers on sidewalks in different locations around campus. They settled. They've been kind of it hasn't been too successful. So you either put them on concrete, which kind of defeats the purpose, or just get rid of pavers altogether. Administration actually came to us over the facilities and said, "Don't do it again. We don't want any more pavers." And I said, "Well, you know what? I'm kind of that way." I said, "I'll tell you what to do. We're going to put concrete out here. We're going to put the pavers on concrete so they won't settle. It'll be a consistent flat surface for the duration. But aesthetically, it looks great. Impervious, stormwater infiltration. It just made a lot of sense. There's a lot of reasons for doing it. So we convinced them to go ahead and let us do it."
So it's permeable pavers on pervious concrete.
Yeah. Yeah.
Molecular biology for one of my classes. We did some exhibition class. We reworked one of those criteria also. And I think they did that. They put the concrete down instead of the gravel.
I didn't work on that project, but that's a good strategy to use for the pavers. Yeah. Probably over there it isn't. This is the only installation we've got so far that has the pavers on top of pervious concrete. Over at ASB, we've got over across the tracks, we've got pervious concrete and asphalt. We did that a few years ago just to see what that was like, see what it would do, and it really has held up well. So you're probably going to see that more and more on campus. So you actually get good infiltration. Snow melts quicker on it. So we're going to see more and more of that here and probably around the country.
Are the pavers wet set in that then, or is there a...
No, there is a granular layer in there,
Okay.
but it's minimal.
Right. All right.
Vegetative roofs, we plant sedum in them. Sedum is very tolerant to wet conditions, dry conditions. It doesn't grow very high. It doesn't need very much maintenance. So it's a really good material for vegetative roofs. There isn't a whole lot of soil in it, so the load on the roof is not any more than what a snow load design is for roofs. That's worked out well also.
You mentioned drainage tiles. What does that mean? Around the building?
Yeah, around the perimeter of the basement and actually underneath some areas of the basement. This was really a wet site. This is like 32, 34 feet below grade. So we got down into the water table. So we need to make sure that we didn't have water pressure down there. So same as you do around the house, you put a perimeter tile around it and you either daylight it or you have a sump pump.
How does that stay clean? How do we sediment out of that?
It's encased in rock, so it doesn't get material in it. It's a perforated tile with small holes in it. But that runs all the time.
And is that on a sump then?
Yeah, we've got several sump pumps. We've got backup sump pumps. We got backup power. We actually had a sump that failed during construction of ABE. So we actually we flooded the auditorium. You guys have had a class in that auditorium. We flooded that during construction. That was not a good day.
So what else did you guys do for LEED, or was it just stormwater stuff?
That's just the stormwater side of it. As far as lighting, we use the LEDs in a lot of locations. A lot of lighting control.
Looks like you get a lot of natural lighting.
A lot of day lighting. Yep. And Ealings, you can walk up there. In fact, we can. If you guys done down here, we can go out in the back of the atrium. Let's go back out. Yeah. I came up here, I guess, to show you one example of this is the small vegetative roof over that entrance. There's another one on the north side, and then of course we've got the large one on top of the Ealings. There's two ways to do vegetative roofs. So here again, I'm probably talking to the choir. This is a pan system, a tray system, where the plants come in. They're all in trays. You just place them out there. On top of the larger area, on top of the building, is it's a planted environment. So everything was planted in a medium. You talked about the other sustainable items. Especially in the office wing, and we'll take a walk through here. We've got offices on the south and the north. A lot of glass, a lot of sunlight. Down the middle are grad offices. A lot of glass again. They use very little light, even down the center. Even though they don't have any exterior exposure, there's enough light that comes in that they don't really have to use their lights in those areas. We got light control, so it automatically turns the lights off, and so that's a nice feature, and we did that on, of course, we did that on purpose. But mechanical systems are very efficient, energy efficient systems. We used in this building. BRL was the first building, so this complex was the first time we used chilled beams for cooling, and we'll see that in Ealings over here. Instead of a normal system is you put chilled water coils at the air handler unit, you blow the air and it comes through with the supply air. That's how you cool spaces. Chilled beams are actually radiators right in the ceiling grid, and we bring the chilled water from campus, run chilled water through there, and we run a real low velocity air over the top of that. So you don't have you get the cooling, but you don't have that chilling effect. You don't have a high velocity system. So it's and of course cold air falls, so it's a very comfortable system, but very energy efficient. We figured this building, This complex together is about twice the size of Howe Hall, and we'll use probably half the energy here than we'll use in Howe Hall. Now, I'm not criticizing Howe Hall because that's how many years old, and the systems have changed dramatically since then. But that just gives you an idea of where we're at, where systems are nowadays. So you've got the stormwater, lighting, electrical, energy efficiency. What am I forgetting here for lead?
Materials?
Materials. Yeah, we used renewable materials. All the carpet in here is recycled carpet. BRL used a lot of bamboo doors, and I'm not really sold on that. You won't find any bamboo in this building. We had our problems with the bamboo product over there, so we didn't repeat that over here. So you got materials within a given range. The brick came basically locally. Recycled materials here. The wood on the wood is certified. In here, so we have certified wood. So definitely materials, and we got materials that are recyclable that can be reused for another purpose and be used. That's a big item too. Yes.
How does heating work? You say you have a lot of windows, but a lot of windows means you're gonna have a lot more heat loss.
You know, there's a
So
happy
how does
medium
that-
there.
Yeah. So how does that work? Do you have like coils in the floor, like you have with the air conditioning, or do you have radiator heat, or how does that?
Yeah, we've got perimeter radiation heat, and but you're right about that. And we use the most high efficient glass within reason, so there's always that trade-off on that. We do have in the atrium, we do have heat in the floor out there. We also have cooling in the floor out there. So we utilize that for that large space, the heating and cooling. The labs, we'll go through there. You'll see the large high bay labs, which are the tractor labs, combine labs, where they got large equipment. We've got heat in the floor in those areas too. It's more of a shop area. There's no better way to heat a shop than heat in the floor.
Is there heat in the sidewalks around here too?
No.
No.
You know, we pretty much have gone away from that. We've just had issues with that, with heaving, with sidewalks not staying in place, and then the lines break. Just haven't been really successful for what it's worth.
Yeah, my experience has been the same with the
But all the water from the lifts comes into here before it gets into a system down, and then it eventually makes its way down to the tanks. Cool opportunity for photo ops. You guys ever been up here?
So are these French drains going right down into the deep tile?
Yeah.
Okay.
Yep.
Yeah, it looks
So
really,
that whole
it looks
area
really
there
nice.
is rock stormwater storage.
Will that ever fill up with sediment, the core spaces? Or, I'm sure that's like something that's being tested, and they'll,
Yeah, it is.
have to try
Yep.
it at least once.
And we talk to our maintenance people, don't put sand on there, don't put anything that can fill up those spaces, so. Good, it's a good try. So we like to push the envelope, we like to try different things.
Is keeping organic matter off of there part of the maintenance? Like, is there a scheduled like leaf blowing? I mean, regular clearing?
we typically do that, yeah.
Okay.
Yep.
'Cause I would think eventually you'd start getting moss.
There's enough systems around that really it takes quite a few years before it's an issue.
Okay.
If you do it, if you maintain it well,
Right.
it's really not an issue.
Okay.
All the soils around here, I probably should have told the group, all the soils around the building are amended soils. We use our university compost. We have a compost facility south of town. I don't know if you guys know
she
that or
taken you
talk
guys out
about
there?
that.
Yeah, we
Okay.
visited there
Did you?
a month ago.
Good. That was another one of our success stories, I guess. When it came time to build the ISU dairy, we had two things. Two things that I wanted to accomplish was we didn't have the land base to put all the manure on field apply it. Besides, it's not the sustainable way to do it. So there's nothing better than dairy manure to compost. So I used part of the dairy farm money to build a compost facility. We use that. We use all yard waste. We use all the manure from all the farms. We compost it. We mix it with good topsoil, some sand. We bring it back to campus. We had a terrible problem on campus around new buildings, new construction. We couldn't grow trees. We couldn't grow vegetation.
Right.
Because contractors were putting junk back in. But now we supply the material. We know what we're getting, and we've had so much more success on plant growth, longevity.
Yeah, that place is really impressive. The first time I visited it, there was snow on the ground, and they were turning the rows, and to just feel the heat coming off.
Steam coming off that. Yeah.
It's wild.
The other part of the dairy that's kind of a cool story is that the other two towers that we imploded, we actually took that concrete out. We totally recycle like 98% of those towers. The concrete went out to the dairy farm. That's before I built the dairy. We got a concrete crusher out there, crushed the concrete, put it on the drives, parking lots, under buildings. So every time they give a tour, they talk to people, tell them they're walking on the towers. And it's surprising how many people can either live there or knew somebody that lived in the towers.
When you make the custom soils for around the buildings, do you have like a hopper to do that, or do you contract someone in to do that work?
We've got a turner that mixes it pretty well. So they put a line of the compost, a line of the topsoil, some sand, and then they take this turner, which is like 12 foot across. Once they mix that a couple times across there, it's a good mix.
Is that the same thing that they use at the compost facility? Because we saw
Yeah,
turn
in
that
fact, that's
thing
what
on.
that's what they use.
Okay.
So you're talking. I mean, we mix it out there, so when it comes to the projects, it's all fully mixed.
Oh.
We tried to mix it on site before, or we had one of the construction managers try to do that, and I told him not to. It didn't work very well. We don't do that anymore.
Imagine that would be a big mess. So like a lot of these soils are very compacted and have a lot of clay. How much do you have to add to those soils to make them?
Well, on a site like this, we make the contractor go down like 2 feet. When they're building the project, they really compact the heck out of it. We make them take that, over excavate that, take that out, mix it up, and then start putting the amended soil in. So as they put it back in, it gets mixed well. So the top 2 feet are good soils. In the planting beds, it's even deeper than that. So we really work it, and we make it drain. Now you get subgrade, it doesn't drain. So what we purposely do is put a slope on that, one direction or the other. So the water, when it goes down, it infiltrates. It actually hits the subgrade, and it still drains. It gets to a perimeter tile. It gets